Hi everyone. Today we're going to be looking at comparing center and spread. Okay, comparing center and spread. Last time we looked at comparing data displays. All right, so let's take a look at what center and spread is. Again, just to quickly review, we know that the center of the data set can be represented by a few things, correct? And the most commonly used measure of the center of your data is the average, right, or the mean. And we also use the median, correct? And the median we know is the middle number, right? And also we can look at center by using the mode. All right, so three things: mean, median, and mode measures are measures for determining what the center of our data is. And of course, a couple of ways that we measure the spread. So just write that down here. So we know that. Hold on. So we also know that. So again, there are certain things we use to determine the center, and that's of course the mean, right, or the average. And we can also use the median, which is the middle number, and also the mode. Okay, these are the three most common ways of measuring where the center of our data is. All right, and we can also determine using certain things what the spread of our data is going to be. So how do we determine the spread, right? How wide, how variable is the spread of our data? And definitely we can use the range, right? Range, so max minus min, correct? We can also use what's called standard deviation, right? Standard deviation. All right, and we've already looked at that in the previous lesson. And again, I told you that it's represented by this Greek letter sigma. Sigma. All right, and we can also look at variance, which is something else that we might take a look at later on. Okay, and variance is just sigma squared. Okay, so these are three things for measuring the spread of data, and these are three things to measure the center of our data. All right, so let's take a look at our problem. So here we have Minneapolis, Minnesota, and Portland, Oregon have very similar latitudes. Latitude measures how far north or south a place is, which in turn affects the temperature. The histograms below show the daily high temperatures in degrees Celsius that were recorded during July 2013 in each city. So here, these are the daily high temperatures during July 2013. Okay, the daily high temperatures for each city during July. So here's Portland, and here's Minneapolis. All right, so what are the questions here? It says, fill in the blanks. The center of the Minneapolis distribution is what compared to the center of the Portland distribution? So if you had to decide on Minneapolis, right, this is definitely left-tailed. This is left skewed because the data is bunched to the right, correct? You could see that the majority of the data is to the left of the center, to the right of the center here. So if we had to like find where the actual center was, it'd be here, but then again, most of the data is to your right. So if I had to decide on the center of this data, it would definitely be to the right. So maybe I would say maybe even 30, okay, or maybe between 30 and 33. All right, but definitely to the right of 30 would be my center of data. As opposed to here, well, again, you have this huge bucket right here between 24 and 27. So it would look like for me, I would say the center of this data is between 27 and 30. So it looks to me like for Portland. So it looks to me like the center for Minneapolis is actually greater than the center of Portland, right? And let's take a look. The variability in the Minneapolis distribution compared to the variability in Portland. So variability for Minneapolis, it looks like it's from 15 to 36, correct? It's very, very wide. It's very, very wide. So that gives us what, about 21, right? 21 degrees Celsius, which is just a range. As opposed to here, we've got a pretty compact range here for Portland. It's 21 to 36. Yeah, it's 21 to 36, which is about 15. So definitely it looks like the Minneapolis distribution is greater in this case than the variability in Portland. Okay, let's take a look at another one. A certain company estimates the reading level of particular books in terms of the minimum grade level of student whom they expect to be able to read and comprehend the book. The box plot below shows the reading level estimates of the top 10 novels selected by a survey of young adults in 2012 and 2015. All right, so here is the reading level estimates of the top 10 novels that were selected by the young adults. So again, we're comparing the center and variability of the distributions. So here, definitely it looks like, again, each for the box plots, remember the whiskers are a quarter and the box represents half of your data. So definitely in this case, it looks like the 2015 center is higher or greater than the 2012 here, correct? In 2012, and also you don't have a whisker down here on the lower part of 2012, so we can say that 3/4 of our data is right here. Okay, the whisker is actually part of your box. So 3/4 of the data is here and a quarter is over here. But definitely the center of the 2012 distribution is less than the center for the 2015. All right. And the variability, well, I mean, we can tell right off the bat, the variability of the 2015 or the 2012 is actually less than the variability of the 2015. All right, so I think it's both going to be less. Yes. Okay. Let's do another one. Baltimore Ravens won the American Football Championship in 2013. In the same season, the Kansas City Chiefs had a record of 2 wins and 14 losses. Okay. The dot plot below shows dot plots below show the 40-yard dash times of the defensive backs on each team's roster. Defensive backs mainly defend against passes, and the 40-yard dash is the main measure of speed used in American football. So again, let's compare. Compare the centers of the Raven distribution with the Chiefs and the variability. So if we look at the Ravens, the center of this distribution looks like it should be somewhere around here, correct? I would say somewhere around between 4.4, less than 4.45, correct? So definitely less than 4.45 would be my center of the Ravens. The center of the Chiefs would be definitely more towards like greater than 4.45. All right, so I would say the center is right here. Okay, so my guess is the center of the Ravens is a little bit less than the center for the Chiefs. Okay, so right about here compared to right about here. The variability in the Ravens distribution, well, definitely it looks like the variability for the Ravens is much greater. All right, so let's take a look here. That is correct. All right, let's do maybe a couple more. The back-to-back stem plot below shows the mass in kilograms of the offensive linemen on the University of Mount Union, the University of Alabama football teams. So this is the mass of the offensive linemen. I mean, there is no comparison, right? It looks like the Alabama linemen are much heavier, right, on the whole, on average, than the Mount Union football players. Okay, so here's the question. Center of the Mount Union distribution. So the center of the distribution, I would say the center of distribution is somewhere in here, right? probably on the 120 something kilograms, right? 120 something. From 122 to 129 kilograms is much less than the center. The center of Alabama is probably up here somewhere, right? So maybe here or here. So it's less than. How about the variability? Well, the variability is we have starting from 110. When you do back-to-back stem plots, we read this backwards, correct? So it's 110. You radiate out again. These numbers go out. So 110 is right here. We have another 110 right here. This is 115, 118, and 118, etc. So you kind of go outward, okay, as you increase, outward from the stem. Okay? And the variability in the Mount Union distribution. So the variability here, well, it's from 110 to about 139, correct? So 110 to about 139, which is about 29 kilograms. But the variability here for the Alabama team goes from 120 to 161, which is 41 kilograms. So the variability is much less. Sorry, less. Okay. Maybe, should we do one more? Well, no, that's about the same. Okay, so I think that's enough. I think that should be enough to get you started on these problems. All right? Okay, take care. Bye-bye.